Hi, I'm Cheryl Leach. In this example, we're going to be looking at the concavity of a function. Well, what do I mean by concavity? Well, when is the graph concave up or concave down? Well, how do I find that? I want to look at the sign of the second derivative. Now, I went ahead and found the first derivative and the second derivative of my given function ahead of time. We've done differentiation for quite a bit, so hopefully you're familiar with all of this. And if you're having any trouble with the details, please feel free to pause the video and take a look at the details of the problem before we move on. Okay, if you're ready to go, let's interpret this information. To see when a graph is concave up or concave down, I want to look at the critical numbers of that second derivative. So let's find out when the second derivative is equal to 0 and when the second derivative is undefined. Well, my second derivative is a fraction, and we know that fractions are equal to 0 when the numerator is 0. So that means that 4 times the quantity 1 plus 3x squared is going to equal 0. Well, if you think about this a little bit, that can never happen. So we won't get any critical numbers from that criteria. So let's move on and look at when the second derivative is undefined. Again, the second derivative is a fraction. It's undefined when the denominator is 0. That means that x squared minus 1 to the third power equals 0. Well, with a little bit of algebra, we can see that this will turn out to be a difference of squares. And by solving difference of squares, we'll see that that denominator is 0 when x is both plus or minus 1. Not only was that a spot where the second derivative was undefined, but it also is a spot of discontinuity on my original function. So it's definitely a couple of places where we want to split my interval. So let's go ahead and take the number line and divide it at -1 and at +1. So we'll have the first interval being -infinity to -1. Then we'll go from -1 to +1, and finally 1 to infinity. So let's take a look at that very first interval. And we need a test value, any number you like between -infinity and -1. Let's just try x equals -2. We're going to take this and plug it into the second derivative and see what the sign of that second derivative is. Well, when I plug a -2 in for x in the numerator, first thing I do is square it. So it becomes a +4. Multiply it by 3, adding 1, multiplying by 4. That's all going to be a positive number in that numerator. When I plug -2 into the denominator, I will end up with a 4 minus 1, which is 3, and cube it. Again, a positive number. I end up with a positive divided by a positive, which means that the sign of my second derivative at -2 is positive. What's my conclusion? Concave up. All right, we're going to repeat the process for my next interval, -1 to 1. Again, choose any point in that interval. A really easy one would be x equals 0. So let's check out the sign of my second derivative. When x is 0, I'm going to square 0, multiply by 3, add 1, and multiply by 4. All positive numbers in the numerator. In the denominator, when I square 0 and subtract 1, I get a -1. And when I cube -1, it's negative. The numerator is positive, the denominator is negative. Overall, the sign is negative. And what does this mean? Concave down. And then we have to check our last interval. Pick anything you like from 1 to infinity. Let's do x equals +2 this time. Right? When I plug a 2 into the numerator, I get a positive number. When I plug a 2 into the denominator, I get a positive number. A positive over positive is positive, and that means that it's concave up. So taking the information I have in my chart, I can see that my graph is going to be concave up on the interval from -infinity to -1 and 1 to infinity. and it's concave down from -1 to +1. I hope this helped. Thanks.